Hello again everybody, and here is the third video with my little line boring adventures for the very first time. The line borings turned out quite nice. I've got a quite nice smooth finish in the bores. I don't know if this camera is going to really give you any idea of what it's like, or if it's just going to be a bit blurry. Sorry if it is, guys, but it is quite nice. What I did find out is that the last bore is actually slightly less, about 0.04 of a millimeter less than the starting bore. So what I mean by that is the bore which came first in the process is slightly bigger. Now I put this down to the brand new brazed carbide tool that I used, and the tip has, well, I guess it's just sort of worn in as it's been going through the lot. So perhaps if I had gave a second run with my carbide tip tool, it might have made everything pretty much equal. So maybe it was because, you know, the tip had a very sharp edge on, and maybe that sharp edge is just worn off in the first few cuts. So I'm not sure, but from this starting hole here, that one is 0.04 of a millimeter bigger than the last one. But I've made my sleeves to suit. Now I've already pressed two sleeves in here, in this one and in this one, and I've got the pin fitting very nice. So I've still got to press two more sleeves in there. I've got them ready. Using acetone to make sure everything's well cleaned, and Loctite 680 afterwards. And there's the glass full of the cuttings from this job. The pin, this is my new pin which I've made myself. It's made out of a material called EN36A, which is a case hardening alloy steel. I found a old-time heat treaters mixture on the internet, mixed it up, and I made a heat treatment oven, electric, which can go, you know, up to 1000 degrees centigrade, and I baked it in that oven along with some other pins for about 10 hours. So that should put a good thickness of case on this. Then I heated it to red heat, quenched it in just old engine oil. So hopefully that's done a good trick. And EN36A is a very high strength alloy steel, so shouldn't be any problems with these pins. I've got a very nice close fit with the new sleeves. So if we put it in there, I'll try and keep this camera still while I'm doing this at the same time. And there we go. That's very nice, very snug. So it's a pretty good repair. Let's hope that the top pin turns out just as good. When I machine the sleeves, because they're going to get pressed in, I have got to make this inside diameter slightly bigger than what I want to finish off with, because I'm expecting, with it being an interference fit, I've worked on about 2 to 300ths of a millimeter interference, which means the sleeve is actually bigger than the hole by 2 to 300ths, and it's going to squash in a little bit, reducing your inner diameter. So I've allowed that in the machining, and it's worked out pretty good. It's often a bit of guesswork, because it's a case of how much does the outer one expand when it's when the sleeve is hydraulically pressed in, and how much does this one contract. And that of course is going to be determined by the thickness and strength of the outside body, and likewise the thickness and strength of the sleeve, or the bushing that you're pressing in. I don't think there's any given rules you could use. It's probably kind of you might even have to do a bit of a test and see how it goes, you know. But anyway, it has worked out good based on my calculated guesses. That's all it was really, a calculated guess, and it's worked out fairly good. I'm not after, you know, super precision or anything. This is just an excavator and they're going to wear out in any case, but I do like to get things nice in the beginning. So yeah, I'm very happy with that. So now I've just got to do the remaining 2 bores, press the sleeves in, and this is done. Then the next thing I'll do is press the old bushes out, which are on the excavator, and press new bushes in. Something very important I've learnt about this. This was not cast steel. This appears to be actually cast iron. Now, I always thought, you know, cast iron, it's certainly not used for a piece of equipment like this, but this is called either ductile iron or malleable iron, and these can actually be quite high strength. Sometimes they are used even instead of cast steel. And the thing about these is it should not really be welded on. I've just tacked, you know, my bearing holders in place. But I've been informed by somebody who does line boring full time that what can happen is the welds are so weak they can actually come apart when you are doing your line boring, you know, and that would be quite a catastrophe. You've lost all your accuracy and everything. So a good test for finding out if anything is cast, or this ductile iron or malleable iron as it might be called, or even cast iron, is you can drill a small hole somewhere where it's not going to affect the strength. Check the cuttings coming out, you know, off the small, seem grey, powdery, it's most likely a cast iron. If they come out shiny and longer, it's more likely it's cast steel. You can put a dab of weld at just some big chunk of the body somewhere, and if it is extremely hard at the where the weld ties into the metal, then it's most likely a cast iron. These cast irons are generally sleeved. I was told by the line boring guys that on this ductile iron, sleeving is an authorized repair, whatever they mean by that. And another guy told me that, yeah, with this stuff he would never build the bores up inside with weld. He would only sleeve them, because once you weld on this cast stuff, there's so much carbon in it, the cooling rate makes it go glass hard. So it's not supposed to be welded on, and the bores are certainly not supposed to be welded up, and then, because you wouldn't be able to machine them. So that's been one heck of a lesson for me. Yeah, the tab here, I'm going to try and lock this solid so it cannot turn at all like that. A lot of machines, I see the tab holding mechanisms allow some movement like this, and to me that's just going to allow wear in the boss. So okay, yeah, here's another view of the bores before any sleeves in, and there's another view, not much in focus. Get one underneath there, get better view of the sleeve maybe. And that's it. I'm very happy it's turned out so good. It's been quite stressful, being my first job, but I seem to have got it good, and I've certainly